Hi everyone, my name is Lucy and I'm studying medicine at UCC. So today we're going to be doing the 2024 higher level question 1 in the physics paper. So this question is a mechanics experiment question which is worth 40 marks. And this one is the experiment to investigate the relationship between the acceleration of a body and the force applied to it. So let's get started. So the first part of this question is to draw a labeled diagram of how the apparatus was arranged in this experiment. So this is my diagram here, so you should have something similar to this, but obviously it could be slightly different. So your diagrams don't have to be perfect or anything, as you can clearly see. But the main thing is to have everything clearly labelled, so that even if it doesn't look like whatever the apparatus is, for example, the dual timer, if it doesn't look like the dual timer, once you have the labels, that's the main thing, so that the examiner can understand what each piece of equipment is. So in terms of marks for this question, there are 10 marks going in total. So you get 4 marks for the trolley here, or rider, or whatever you call it. I know there's different names, but it's basically just the object that is moving down the air track. So 3 marks then are given to the applied force, which here it is the slotted weight because they are attached to the pulley and they are pulling the trolley down the air track. And the last 3 marks of this part of the question are given to the photo gates. So the main thing is, they're the main 3 points to have, the main 3 things to have in your diagram. So it's worth 10 marks overall, but it's really important to remember your labels, as you may lose a mark if they aren't on your diagram. So part 2 of this question is describe how the student determined the acceleration of the body. So in this experiment, the trolley passes between the 2 photo gates with a card of length L on top of it to cut the light beams. So the photo gates are attached to the dual timer, so the time at the beginning and the end of the air track can be seen on that dual timer. So you get 3 marks for mentioning that you are measuring the time interval here with the timer. So that's 3 marks there. So then the student found the initial and final velocity of the trolley. And so obviously, as we know, velocity is equal to displacement over time, which is these equations here. But a handy way to remember it, in case you sometimes can get confused, because it can be tricky with all the different letters, this little triangle over here can be handy. So the D stands for displacement, V is velocity, and T is time. So if you cover up the one that you are looking for, so in this case we're looking for velocity, then you know that it is displacement over time. So 3 marks are given for calculating U and V here. So we've got another 3 marks already. Then to find the acceleration, we are going to use a formula here on page 50 of our tables book. We are using this equation right here. V squared is equal to U squared plus 2AS. And so you get the final 3 marks of this part of the question for using the relevant formula at the end to get the acceleration. So in this case it is V squared is equal to U squared plus 2AS. So part 3 of this question is to draw a suitable graph to show the relationship between F and A. So this is my graph here. So the main things to remember when drawing a graph is to label your axis correctly. So here I have my y-axis labelled as acceleration and the x-axis is labelled as force. And so also when you're labelling them, to remember to scale them correctly, because you start at the origin and then you have a set amount that you increase by at each point. So for example, on the x-axis here with force, every 10 boxes I went up 0.1. So that is in equal increments each bit. And so for labelling your axis correctly, 3 marks are given. It is also too important to label your graph with the title of the experiment on top here. So in this case, it's acceleration versus force, or the relationship between them, because in case you're doing your questions out of order in the exam, or if your pages get misplaced, it's important to have them labelled so there's no confusion about which question it is. In this question, it's important to note that the force is on the x-axis because it is the independent variable, so the one that we change because we differ the amount of slotted weights that are hanging from the pulley, and then acceleration is on the y-axis as it is the dependent variable, so it is affected by the force. So 2 final things to remember is drawing your line of best fit, which I have here in purple, and to write the units on the axis. So 3 marks are given for the line of best fit, and then the final 3 marks of this part are given to just having your points plotted in the correct position. So part 4 of this question is asking us to explain how your graph verifies the relationship between F and A, which of course is force and acceleration. So the graph displays a straight line through the origin, 0, 0, which shows that A is directly proportional to F. So you get 3 marks for saying that statement is short enough. And then this next part isn't required for getting the marks, but it helps with understanding the next part of the question. So this directly proportional relationship between A and F means that A is also equal to a constant multiplied by F. And we know this because you can change any proportionality, so something that is proportional to another value, into an equation by multiplying them by a constant. So before we go on to part 5, I just want to bring your attention to page 18 in the tables book right here. So we're going to be using 2 formulas from this in part 5. That is the slope formula and the equation of a line formula, y is equal to mx plus c. So part 5 is asking us to use the graph to calculate the mass that has been accelerated. So this is the graph that I drew earlier. So first of all, to begin, we have to find the slope of the line of best fit, which is the purple line that I drew. So you pick 2 points on the line of best fit, so I picked 2 that are on either side of the line. But the main thing is to make sure that you do not pick any of the points that you have already plotted, the ones that they gave you in the question. So I tend to pick one near the lowest and the highest points already plotted, so I've marked them with a pink X here. So this is x1, y1, and this here is x2, y2. So now we are going to put these 2 points into the slope of a line formula, and just remember here that m means slope, not mass, so we'll get to the mass in the later part of this question. So we know the slope formula is y2 minus y1 over x2 minus x1, which is what we found in our tables book. So we're just going to fill this in with our values. So I'm just going to put it all in the calculator now. So you're going to have the fraction button. So it's 1 minus 0.27 all over to be divided by 0.71 minus 0.19. So then we get an answer. So the slope is 1.404. So just a reminder there that this is the slope, it is not the kilograms. So now we have the slope, but we need to see how it relates to the mass. So we know that the equation for force is that force is equal to mass by acceleration. This is in a tables book, but also we know it by now. It's come up a lot in the physics course. So we can rearrange this formula a few times to get what we want. So we can rearrange it first of all to have force divided by mass is equal to acceleration. Then we can have force multiplied by 1 over the mass is equal to acceleration. Therefore, that just means that the acceleration is equal to 1 over the mass multiplied by the force. And if we compare this equation to the equation for a line, y equals mx plus c. However, there's no need for the c in this case because the c is the y-intercept, but as you'll remember in our graph, it went straight through the origin, so it did not intercept the y-axis. So it's just y equal to mx plus c, and then if we put our other formula here, A is equal to 1 over the mass multiplied by the force, we can correlate that the y-axis is the acceleration, the x-axis is the force, which we know, and then now here we know that the slope is equal to 1 over the mass. So this is when we come back to what I said in the previous part of the question, that since the acceleration is proportional to force, acceleration is equal to a constant multiplied by a force. And in this case, the constant is 1 over mass, so the slope of the graph is 1 over the mass. So finally, to calculate the mass, we are going to find the inverse of the slope. So the mass is equal to... So finally, to calculate the mass, we need to find the inverse of the slope. So slope is equal to 1 over the mass. So that means that the mass is equal to the inverse of the slope. And we know we can pop this into our calculator now. So our slope was 1.404, and then to get the inverse we click Shift and then the inverse button and equals. We get a value of 0.71. So that's just saying now that we have our mass to be 0.71 kilograms. So kilograms obviously important to remember your units here. So there are 3 marks given for finding the correct mass, and then also 3 marks for using the slope formula right up the top here. So it's 6 marks in total, this part of the question. And now we're on to the last part for our question, part 6, which is worth 4 marks in total. They're asking us to sketch the graph a student would get if they did not account for the presence of a constant frictional force of less than 0.2 newtons. Since they said sketch, you don't have to draw it out on graph paper. You can just draw it in the answer book. Just make sure to use a ruler to try and keep it as neat as possible. So you get 4 marks for just sketching this graph. And the main thing just to remember is that the line of best fit does not go through the origin. It starts from about here roughly, where it is an x-intercept, so it doesn't go through the origin. So this here is a side note. It's not required to get your marks, but it kind of explains the answer if you're a bit confused. So it explains that this is a non-zero intercept, so it doesn't go through the origin. And then this indicates that some amount of force is needed to overcome the friction before any acceleration is observed.